Hi, calculus students. So I just wanted to give you some more examples to help you know when an estimate that you form from the tangent line is an underestimate or if it's an overestimate. So the way to determine an overestimate or an underestimate is to look at the second derivative. So what the second derivative is are the slopes of the function f. So you're looking at the slopes. And so if the slopes are increasing, and so I know that this blue curve the slopes are increasing because if I were to draw tangent lines, like let's draw tangent lines at these 4 points. The slopes of the tangent lines start negative, but they start to level out, and then they turn positive, and then they get even more positive. So that top curve, the slopes are increasing. Since the slopes are increasing, that means that the second derivative, So that means the second derivative is positive. So when the second derivative is positive, we call that concave up. And so I drew that little smiley face, refers to concave up. And then you know that your estimate is an underestimate. And you can see all the tangent lines that I drew are they're all under the curve. So it's an underestimate. Likewise, if I look at the second curve, and I could draw tangent lines. Look at these tangent lines now. They start off positive, and then they turn negative. So the slopes are decreasing. They start positive, then they turn negative. The slopes are decreasing, which means the second derivative is negative, and that is concave down like a frown. This one fits better. So that's where the smiley face and the frowny face comes from. You can think concave down like a frown, and you see how the smile and the frown show you what the curve will look like. So when the second derivative is negative, it's concave down, and all of your tangent lines are overestimates. They're overestimates. And if you look at my tangent lines, you can see they are over the curve. So here is the summary table that we're going to use to guide us in the problems. So this first problem should look familiar. In fact, you can do part A on your own, and I recommend you try to do part A all on your own. But I will also do it for review in case you were confused in class. So we have a differentiable function g, and I know that g of 2 equals 7, g prime of 2 equals -3, and g double prime of 2 equals -5. So part A wants me to use the tangent line to approximate at x equals 2 to estimate g of 2.1. So I'm going to write an equation of the tangent line using x equals 2. So I'm just going to note that. So my tangent line will be y minus f of 2 equals f prime of 2 times x minus 2. So, except my function is not f, it's g. So I'll replace these g's with f, or these f's with g's. There we go. I know g of 2 equals 7, g prime of 2 is -3. So there's my tangent line. And then I'm going to use the tangent line to approximate when x equals 2.1. So I'm going to plug in 2.1. So y minus 7 equals -3. Oh, we didn't do this problem in class, but it's similar to what we did in class. Try that mental math on your own. So I got g of 2.1 is approximately. I'm going to change that equal sign to an approximately because this is an approximation that I used from the tangent line. And now part B says, is the approximation in part A an overestimate or an underestimate? Give a reason for your answer. So this is where I'm going to use the second derivative. The second derivative helps us to determine over and underestimates. So I will note that g double prime equals, well, g double prime of 2 equals -5. So I know g double prime of 2 is less than 0. G double prime is negative. So looking at our table, when the second derivative is negative, my function is concave down, which means the tangent line gives me an overestimate because the tangent line is over the curve. So if you didn't have that table, you could just draw a quick sketch. You're like, okay, so g double prime is negative. So g is concave down. And if you're like down like a frown, and then the tangent lines are above it, you could even draw quick tangent lines and say, look, those tangent lines are above it. And so I would say, therefore, what was the value? G 2.1, approximately -7.3, is an overestimate. An overestimation. Okay? So I answered the question. I said it's an overestimation, and I gave a reason why. And the reason why, right here, give a reason why, is that g double prime is negative, so g is concave down. Okay. If you want one more example, we'll do one more example together. So let f be a function such that at each point, xy on the graph of f, the slope is given by this. I know it's kind of hard to read. So there's my slope. The graph of f passes through this point, and it is concave up on the interval. So that's my important information. Let k be the approximation of f of 1.3 found by using the locally linear approximation of f at x equals 1. Which of the following statements about k is true? So k is the approximation of 1.3. K is approximately f of 1.3. So I'm going to use the tangent line in order to find what k is. So my tangent line, and I'm looking at x equals 1. So I'm going to fill in y minus f of 1 equals f prime of 1 times x minus 1. So here is my point. That tells me that f of 1 equals -2. And then I can use my derivative. There we go. I can use my derivative by plugging in the point. I'll plug in 1, -2 to find what the slope is, because the slope will tell me the derivative, right? So I know that dy dx equals 1/2 times 1 minus 1/4 times -2 squared. So I'm just really cramped. I'm really cramped, sorry, but I'm plugging in 1, -2. And if I do some mental math, I get 1/2 minus 1, which is -1/2. So my slope is -1/2. And I'll plug those into my tangent line. So I have y minus -2 equals -1/2 times x minus 1. Okay. And then I'm going to use that tangent line to estimate the value of y when x equals 1.3. So I'll plug in 1.3. This is really making me do some annoying math, huh? So 0.3 divided in half would be 0.15. I really had to think about that. And then I'll make it negative because there's a negative sign there. And then subtracting 2. So this is negative 2.15. So there's my value of k. Let's see if that is an option. Yes! Okay, so I know it's not A, I know it's not B. So it's C or D, and then I need to know whether it's an underestimate or an overestimate. So I'm going to use my concavity. It's concave up. So concave up is like a smile. And when I draw on the tangent lines would be underneath the curve, so that is an underestimate. There we go. Hopefully this helps you out. You will see problems like this on the AP exam, where you will have to find an estimate and really just rely on your tangent line.